Awesome, awesome, awesome. I'm glad I can see quite a couple of our students joining in. Ladies and gentlemen, welcome to a Student Affairs series. This season two of the series is themed Fundamentals of PVT Analysis, Key Concepts, and applications in reservoir engineering. I would like to appeal to you that this event is live streamed on YouTube, so you always have the opportunity to always revisit YouTube and rewatch the training. My name is Ofofonono, and my pleasure it is to serve as your MC for today. I'll kindly appeal to all of our student members that please you start the event by renaming your device. Let's have your name first and then the name of your university so that we can know and track the student chapters that attend SPE Abuja event. I'll continue the event by making you understand that this is the order of event for today. Of course, it starts by 4 o'clock. After my opening introductions, I'll give the safety brief, and then we'll recognize a few VIPs that have joined us here today and our speakers. After that, we would, of course, have a remark by our section chairman, and then we have the session by the graduate trainee from Cypher Crescent, after which we'll have and give the opportunity to ask questions. And then we have the vote of thanks by our Assistant Student Affairs Chair. Ladies and gentlemen, it's going to be a very, very brief and yet intellectual discussion. So let me start the event, of course, by giving the safety brief. First of all, and very importantly, please leave your microphone on mute. Should you want to speak, please raise your hands to speak. You can use the C for comments and Q for questions on the chat box. And of course, we would attend to all of your questions. We also ensure that you can hear a fire alarm if you're using your headset. We believe it's going to be a very, very interesting deliberations today. I'll continue the event by recognizing some amazing personalities that have joined us here today. Please, when I call on your name, we kindly appeal that you just tell us good evening and probably tell us where you're joining us from. I'll start by saying a warm welcome to our amazing section chair, the leader of SPE Abuja section. Ladies and gentlemen, please help me welcome Engineer Ikechukwu Okafor, PhD. A very warm evening to you, sir.
Thank you, Akpan. Good afternoon, everyone on the call. I'm joining in from Lagos. It's good to be here. Thank you.
Thank you so much, sir, for leading the section to excellence as usual. Of course, this event is in partnership with Cypher Crescent. My pleasure it is to welcome the technical director and CEO of Cypher Crescent here present, the triple helix model boss, Tangod Egbe. A very warm evening to you, sir. Confirm you can hear me, sir.
Okay, I can hear you. Thank you so much. I just joined to listen to my colleagues who are presenting and learn from them. Thank you so much.
Awesome, awesome. A boss who wants to learn from his colleagues. Amazing one, sir. We're also pleased to have here with us, ladies and gentlemen, the most hardworking assistant student affairs chair ever. The one and only Chinaza Enwere. A very warm evening to you, ma'am. Confirm you can hear me too.
I can hear you. Good evening. Good evening, everyone. I'm excited to be here. Thank you.
Yeah, Chinaza, we celebrate your tenacity of purpose and everything you do for SP Abuja section. And of course, if you can see my screen, the lady that will be speaking to us today, the ever smiling Obaze Daniela, a graduate trainee of Cypher Crescent Limited. Good evening, Daniela.
Good evening. Good evening, everybody. I am so happy to be here today, and I am joining from Port Harcourt.
Awesome, awesome, awesome. Thank you so much, Daniela, for accepting to speak to all of our student chapters. I would like to also add that Daniela was the first person to join this call, even as a speaker. We celebrate your punctuality, ma, and we are so excited to have you in SPE Abuja section. We welcome all of our amazing students chapters here present. Please, student chapters, like I said earlier on, kindly rename your device. Let's have your name first and then the name of your university chapter. I'm yet to see anybody do that. Please do that so that I can know the student chapters here present. We welcome all of our student chapters from NEL University to Base University to ATBU to BUK to Maiduguri, and all of the student chapters we have in Abuja section. Thank you, Futimina, for joining, and of course, all of the amazing student chapters. We continue the event, of course, by listening to our leader, the champion of excellence in SPE Abuja. Ladies and gentlemen, help me celebrate Engineer Ikechukwu for PhD for his welcome address. Over to you, sir, for your remarks.
Yeah, thank you, Akpan. Good evening, everyone. I'm still on transit, but yet I have to speak to welcome all of us to this skills development series. It's a series that was born out of the need to ensure that our students are not left behind in the pursuit of development, personal and career-wise. So SP Abuja had thought it wise to ensure that we keep our students abreast of the latest development in and around the oil and gas industry. And we have a very wonderful partner. We have a very wonderful partner in Cypher Crescent, who had been a formidable collaborator in everything positive for XP Abuja. And so today we are having this session to speak to a need that is very critical, talking about PVT. For those of us who have started taking reservoir engineering courses, would find this session very, very impacting. And for those of us who would yet take it, it is a welcome to the possibilities of what a knowledge of PVT can do to us. Daniela, you are welcome. Thank you for accepting to make this presentation and impact our students so that we get the benefit of today's session. On that note, and on behalf of SP Abuja and the board, I want to welcome everyone to this skills development series hosted by SP Abuja in partnership with Cypher Crescent Limited. Thank you and welcome.
Thank you so much, section chair. Thank you so much, section chair. Please, can I see some virtual applause for Engineer Ikechukwu for PhD? All you need to do is to type in the comment section culture of excellence. Just type in the comment section culture of excellence. Of course, you know that is our motto for SP Abuja section. When we say SP Abuja section, respond with culture of excellence. So excellence just spoke. So can I just see on the comment section culture of excellence? Culture of excellence. Yes, 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 yes. I want to read them. I want to see the first person that will type that on the comment section. Let's see who will be the first person who is the most excellent. Melissa Ekuma. I like that. Melissa Ekuma is our champion of excellence for today. Amazing, amazing. Adeyinka, I see that from ATBU. Amazing, amazing, amazing. If you can see your screen, you have a few reasons why you should attend this event till the end. You understand the vital role of PVT in reservoir characterization and simulation. You also learn PVT sampling techniques and laboratory best practices. You also master the interpretation of PVT reports to drive smarter field decisions. And most importantly, you sharpen your technical edge with practical insights from industry-ready professionals. This event is a 2-day event. Today from 4 to 5:30, and then tomorrow, which is Friday, from 4 o'clock to 5:30. So please endeavor that you attend the 2 sessions. After Daniela's session today, you will have 20 minutes to ask her all of the questions you may want to ask. So please endeavor to type your questions on the chat box while she's training you, so that after that, we will compile the questions and she will do justice to all of the questions. Ladies and gentlemen, introducing Daniela Obaze. She is a recent graduate of Petroleum and Gas Engineering from the University of Port Harcourt, where she earned a second-class upper division degree. She also holds a mini MBA from Lagos Business School, Pan Atlantic University. She's an active member of the Society of Petroleum Engineers and, of course, has served in multiple leadership capacities, including the Vice President of the SPE Uniport chapter, where she led impactful projects and received several awards. Her passion for innovative technology is evident in her recognition as an Energy Challenge winner at the SPE Students Technical Symposium and Exhibition. Of course, Daniela is currently a graduate trainee at Cypher Crescent Limited, working in the Digital Services Unit. Ladies and gentlemen, drum rolls, help me welcome our graduate trainee, Daniela Obaze, for the next 40 minutes as she drills us on the theme fundamentals of PVT analysis, key concepts and applications in reservoir engineering. Over to you, Daniela.
Thank you very much, Opanon. Good evening, everyone. It's a pleasure to be here. I want to first of all say thank you to my boss, Mr. Thangood Igbe, for this opportunity, and thank you to Abuja section, especially the section chair, Dr. Ikechukwu, and the student affairs chair for this opportunity. Today, I would be taking you on PVT. And we're going to try to make the section as interactive as possible because I believe that the learning is going to be a two-way process. I would learn from you and you would also learn from me because I know there are a lot of people on Discord that also have an idea of what PVT is. And so we'll be doing an exchange of knowledge. So before we go on, I would like to share my screen, but just to know the people we're dealing with, can you please type your department and your level in the chat box? Let me know if we have 100 level students, 200 level, or our majority is the 500 level. Can we go on to do that? Thank you very much. Please confirm you can hear me.
I hear you very well.
Okay. So please, can we go on to do that? Just text your department and your level, because I'm aware we have some chemical engineers, petroleum engineers on the call. Okay, I'm seeing petroleum engineering, petroleum and gas engineering, 300 level, 500 level. Okay, that's wonderful. So like I said, it will be exposed to what PVT is. Confirm you can see my screen clearly, please.
Yes, you can
Okay,
expand
thank
it a
you.
little bit. You can expand it so that we can
Yes,
in slide mode.
So is it full now?
Yes, it is full now.
Okay, thank you. So welcome to today's session on the fundamentals of PVT analysis. My name is Daniela Obaze, as I've already been introduced, and I am a graduate trainee at Cypher Crescent Limited. This PVT training is going to span for 2 days, today and tomorrow. So I'll take the session today. Then my colleague Samuel Ogundele on the call is going to take the session for tomorrow. So the outline of our PVT presentation is you would gain an overview of what PVT analysis is. You're also going to understand the classification of PVT parameters. We would look at the various sampling methods we have in order for us to carry out our PVT analysis. And we would also look at the sources of PVT parameters. This PVT that we're speaking now, where do we get the PVT parameters from? Then we look at the element of what a PVT report is. So we're going to display a PVT report and show how to extract information from the PVT report. So what is a hydrocarbon system? Or when you hear hydrocarbon, what do you understand by hydrocarbon system? Like I said, it's going to be an interactive session. So if we have, please, if we have anybody raising their hand on the call, please let me know. Or if we have answers in the chat box, let me know too. What do you understand by hydrocarbon system? Or where is hydrocarbon gotten from? How is hydrocarbon formed? Let's begin from there. So I'm going to try to make this as simple and taking it in a storytelling version so we can understand the concept of PVT or why PVT actually stemmed in the first place. But if we do not have anybody, I will just go ahead to say, so hydrocarbon is formed from the decayed, decomposed organic minerals that are buried thousands and hundreds of feet underneath the ground, and they've been exposed to extreme temperature and pressure conditions. That's how hydrocarbon is formed. And the hydrocarbon system now found in our petroleum reservoir. Hydrocarbon system composes of hydrogen and carbon. Hydrocarbon system mainly is hydrogen and carbon. Then we have impurities in it. Impurities such as your nitrogen, your hydrogen, sulfide. Those are impurities that all of this is what forms what we call here the hydrocarbon system. So it is a combination of hydrogen and carbon, and carbon ranges from C1, which is methane, through to heavier compounds. It's made up of, we have well-defined and undefined fractions of the hydrocarbon system. Our well-defined hydrocarbon system includes methane through to heptane. And we also have a fraction of the well-defined system being the impurities that we can measure. Your nitrogen, your hydrogen, your H2S, your CO2. Those are impurities that make up the defined fraction of our hydrocarbon system, while the undefined fraction of our hydrocarbon system, which is also known as the plus fraction, consists of heavier hydrocarbons, that is from the C7 plus through to C45 plus. This is what makes up the hydrocarbon system. And the hydrocarbon system now is found in a reservoir, and it's mixtures of organic compounds, like I've already said, and they exhibit multi-phase behavior. When we say multi-phase behavior, we mean they can be in form of liquid, they can be in gaseous state, they can also be in solid state. When you look at asphalt and the likes of hydrocarbons that come in solid content. So this is what makes up the hydrocarbon system. Now looking at this, please hold on. Yes, so this diagram to my right is something that I feel a couple of us will be familiar with. This is called a PT diagram, also known as a phase diagram. And this diagram is used to explain or show how our hydrocarbons exist in different phases. So this plot here, this curved line is known as the our phase envelope. These are phase envelope, and this depicts our saturation point. So if you look here at this critical point, like we already know, our critical point is the temperature and pressure at which our liquids and our gas exist at equilibrium. So this point here is a critical point. And knowledge of this, why this phase diagram is important, like I said, it tells us, or it explains to us how our hydrocarbons behave. So to the left of the critical point, that's from point A to point C, we have the bubble point curve. And the bubble point curve is known as, that is the, above the bubble point curve, we have all our hydrocarbons existing in liquid phase. So which means if we have any hydrocarbon above this bubble point, if we have any hydrocarbon around this pressure and around this temperature, high above this line A to line C, our hydrocarbon will exist in liquid phase. While if we have a hydrocarbon with a pressure if we have a hydrocarbon with pressure around this, our point C to our point D, if our temperature and pressure of our hydrocarbons range from this point to this point, we say that our hydrocarbon exists in a gaseous state. And we know that our bubble point is the temperature and pressure at which we note our first bubble of gas. So once we have our hydrocarbon hitting this bubble point curve, we're coming from a place of higher pressure. Looking at our y-axis, our pressure graph, our y-axis is where we have our pressure being plotted, while our x-axis is where we have our temperature being plotted. And as you go up, you have increase in temperature. As you also move to, you have increase in pressure, while as you move to your right, you have increase in temperature. So we have, let's take for example, we have our hydrocarbon coming from this increased temperature and the temperature, this increased pressure, and our pressure, we're experiencing pressure drop. When our pressure drops up to this point here where we have our bubble point curve, we can note our first bubble of gas being evolved from that liquid. Well, if our hydrocarbon is in a gaseous phase and the hydrocarbon is moving from if our hydrocarbon is in a gaseous phase and we experience pressure drop and it gets to the dew point curve, we experience our first drop of liquid. Condensation occurs at that point, at the dew point curve, while at our bubble point, we experience evaporation from our liquid. To note, we have different types of reservoirs. We have oil reservoirs and we have gas reservoirs. How are these reservoirs being classified? When you have your temperature of your reservoir above the critical temperature, that is a gas reservoir. Or gas reservoirs have been noted to have temperatures higher than the critical point. While oil reservoirs are reservoirs with their temperature lower than the critical point. And this information is gotten from the geophysicists or geoscientists when they do seismic survey. They get the initial temperature of our reservoirs and they get the initial pressure. All of this is used to make inference on our reservoir for us to know what kind of reservoir we're dealing with, if it's an oil reservoir or a gaseous reservoir. And when you identify if it's an oil reservoir or a gaseous reservoir, you also need to identify if our reservoir is in a saturated state or is in an unsaturated state. And an undersaturated reservoir is a reservoir with the initial pressure greater than the saturation pressure. If our reservoir pressure is greater than the saturation pressure, or if our reservoir pressure, yes, is greater than saturation pressure, we have an undersaturated reservoir. But if our reservoir pressure is greater than our bubble point pressure, we have our undersaturated reservoir. And the undersaturated reservoir is noted to be in one phase. So when we have our pressure greater than our saturation pressure, which in this case might be bubble point pressure or dew point pressure, because saturation pressure can either be bubble point pressure or dew point pressure, depending on the type of reservoir you're dealing with. So once you've identified if it is a gaseous reservoir or is an oil reservoir, then you identify whether it is in a saturated state or an undersaturated state. So if the pressure of your reservoir is greater than that of if the initial pressure of the reservoir is greater than that of the saturation pressure, we can say it is an undersaturated reservoir and it will exist in one phase. So for the gas reservoir, it's going to exist in all gaseous phase, while for the oil reservoir, it's going to exist in liquid phase, oil phase. But that doesn't mean that we don't have gas or oil embedded in either of these two reservoirs. So coming from when you experience a reduction in pressure in a reservoir that is purely liquid, which is in this case an undersaturated reservoir, once it gets to the saturation, once our pressure depletes up onto the point of our saturation pressure, then you experience gas evolving from your hydrocarbon. And once you go further, looking at this point E to point F, these dotted lines inside our phase envelope shows how much, like what the content of our hydrocarbon is. We're coming from liquid state, purely liquid state. We get to this point, we experience gas in the reservoir. The gas at this point will be very minute. But when you move down to this first quality line, you're having a liquid of about 90% with a gaseous phase of about 10%. And the more your pressure depletes, the more you go down, because as pressure depletes, we have gas evolving from our liquid. So the more you deplete in your pressure, the more gas solution, the more gaseous phase we have. So as we reduce the pressure, this quality line shows us the amount or the percentage of liquid we'll have as opposed to the percentage of gas we would have. That's the ratio of the liquid and gas in our reservoir. Now, why is the knowledge of the state of our reservoir important to us? Information of our physical properties including the porosity of your rock, the permeability of your rock, and the information of the phase of your hydrocarbon is very important, because it gives us information on the different kinds of hydrocarbon reservoirs we have. I've said we have oil reservoirs and we have gas reservoirs. But in our oil reservoirs, we have what we call black oil reservoir. We have volatile oil reservoir. For the gas reservoirs, we have retrograde condensate gas reservoir. We equally also have wet gas reservoir and dry gas reservoir. And all these types of reservoirs that I have mentioned, they behave differently. They don't behave in a particular way. So how the dry gas reservoir now is one in which your hydrocarbon is in gaseous phase in the reservoir, and even when it comes to the surface, the temperature and pressure condition at your surface is different from the temperature and pressure condition in your reservoir. In our reservoir, we assume that the temperature is constant, which means our reservoirs are isothermal, but they experience pressure loss at different points in the reservoir. So when hydrocarbons move from a place of higher pressure and higher temperature to a place of lower pressure and lower temperature, they behave differently. The black oil reservoir behaves differently from the wet oil reservoir, and all of this information is important. The reason why we study this PVT analysis is important because it helps us understand how these different types of reservoirs behave. Now, what is your role as a petroleum engineer, or why is this PVT analysis or the information of how our reservoirs behave, why is it important to you? Your role is for you to study the types of reservoirs we have and how they behave, because the knowledge of this would help in inferring how the production of these reservoirs will be. The goal in the end is for us to be able to drill oil and gas at commercial quantity. We need the quantity of hydrocarbon in the reservoir to be economically viable? And how can we find out if how can we know if the quantity of our reservoir is economically viable? Is when you carry out this PVT analysis, and it also helps us in knowing what kind of methods we use in the production of this reservoir. Hence why you study the PVT analysis, or hence why you need information of PVT analysis, because every information that you will get from this analysis would help in knowing the reserve estimation. It will also help in knowing the production technique. So having explained or having given background information as to what hydrocarbon is, the different kind of reservoir we have, now we'll move to what PVT analysis itself is. So PVT stands for pressure, volume, and temperature. And PVT analysis now is the study of our reservoir fluids to understand their phase behaviors, the volumetric properties, and the composition as pressure and temperature vary during production. What exactly is this saying? So PVT analysis is the study of the fluid properties. Hydrocarbons, we have rock properties and we have fluid properties. Rock properties including the porosity of your rock, the permeability of your rock, the saturation of your rock, and all those information, your compressibility, density. We also have fluid properties, of which I would explain in the course of this session today. And the PVT analysis studies these fluid properties and how they change when they undergo varying pressure. Because, like I said, the temperature is assumed to be constant in our reservoirs. That's constant temperature, isothermal. We assume an isothermal state. But pressure changes when it passes through different nodes. When the fluid moves from one point to one point, there's a decrease in pressure or a depletion in pressure observed. So PVT analysis basically studies various fluid properties and looks at how they change with respect to pressure change, and also how the volume change, how the density and these properties, our fluid properties, how they change with respect to pressure. Why is PVT analysis important? PVT analysis is very important in our reserve estimation. We need the information of how much quantity of oil is underneath the ground. Why should we go and drill? Or why do you think this location or this why should we drill? Why should we produce this well? Why do you think this is us making investment in this project will be of benefit to us? The only way you can find out if investment in a particular well or a particular reservoir is going to be of importance to you is when you can know the volume of hydrocarbon sitting in that reservoir. That is the reserve estimation. So information of your reserve estimation, or you can only calculate your reserve estimation. You can only make inferences on how much quantity we have in our reservoir when you carry out PVT analysis, because from the PVT analysis, you get information like your formation volume factor, which is used in the calculation of your STOIIP. I'm sure a lot of you know what STOIIP is, your stock tank oil initially in place. So this BOI that is usually given in questions that, calculate the STOIIP when given this formation volume factor, when given this water saturation content, when given this area or this height or this depth of your reservoir. BOI is gotten, or your formation volume factor, because we have formation volume factor for both oil and gas. But the information of your formation volume factor is gotten from your PVT analysis. And not just that, you have your RS, which is known as your gas solubility, or your dissolved gas oil ratio, is gotten from your PVT analysis. Your density, the density of your crude or the density of your hydrocarbon is gotten from your PVT analysis. Also the viscosity, all this information that you use in the calculation in your different correlations in classes, where are they gotten from? They are gotten from the PVT analysis. This is one of the importance or one of the relevance of PVT analysis, because it helps in estimating how much quantity is there. Not just how much quantity, it now helps in also estimating the ultimate recovery. Let's take, for example, we have let's say we have 100 meter cube of oil or hydrocarbon in a reservoir. We know that we cannot drain, or we cannot drill or recover all the 100-meter cube of that, or 100 barrels, 100 barrel of oil in our reservoir. Why? Because there's always, your reservoir will deplete, it will deplete pressure in such a way that you don't have pressure again to drive the reservoir. So there's always going to be remnants of your oil or hydrocarbon still in your reservoir. The information now that we need from that reservoir is, okay, how much of this oil that we have, how much of this 100 barrel of oil that we have can be recovered, which is known as your ultimate recovery. And the information of your ultimate recovery is gotten from your recovery factor multiplied by your STOIIP. So estimation of how much quantity of oil or gas can be gotten, how much is economically viable, is gotten from the parameters, our PVT parameters. The next or another importance or relevance of our PVT analysis is that it helps in flow assurance. It helps in the knowledge of flow assurance. So as a petroleum engineer or in the oil and gas industry, after you have discovered there's oil, you want to drill this oil, you want to produce this oil, then separate different components of your hydrocarbon. You want to separate the crude oil from the natural gas and also the impurities. And you want to be able to export it to be able to get money from it, because at the end of it, we're doing it to what? Maximize profit. In order for you to be able to carry out all these activities I have mentioned, the process of separation, the process of exporting of our crude oil, you need to design your facility. There are a lot of things that goes into it. You need to drill a well. You need to have your separation, your production facility, where you have your separators that separate the different components of a hydrocarbon. And the designing of this facility and the designing of your pipeline can only be done when you have information of the crude oil, or when you have information of your hydrocarbon system. So information that helps in the designing of because you want to design a facility in such a way that you want to design your facility in such a way that you don't have problems that are being faced in the oil and gas industry, problems like your hydrate formation. I'm sure a couple of you know, or you must have heard hydrate formation. Hydrate formation is a threat to the oil and gas industry because hydrates are crystalline structures that are formed under low temperature and high pressure. And this is formed from gas condensation. So if we transport our gas at a temperature where it condenses and forms hydrates, it then clogs your pipeline. And you don't want to design a system that is that way, that clogs your pipeline, and you cannot be able to transport your crude or make profit from what you have drilled. So information of your crude oil is important in the designing of our facility. It is very important in designing a facility that you are sure that the flow will go seamless, which is known as your flow assurance. So it helps to determine your phase behavior, such as your dew points and your bubble point pressure, which are very important for preventing hydrates and liquid dropout. And it also aids in the estimation of your fluid properties like viscosity, because if you also flow a fluid that is highly viscous and can't pass through your pipeline, your fluids or your pipeline gets stuck, and the end game or the end point cannot be achieved because we have a stuck pipe. So information of your PVT or information of your viscosity, density, formation volume factor, and all those fluid properties are important in your flow assurance. Another importance or relevance of PVT analysis, where it comes in very handy, is in our well bore hydraulics. That is in designing of our well bore. You know, we have what is called the vertical lift performance. We have what we call inflow and outflow performance relationship, your VLP and your IPR relationship. So we want to flow the inflow of your reservoir, your hydrocarbon system, is the ability to be able to flow your hydrocarbon from the reservoir into the well, while the outflow is the ability for you to flow your hydrocarbon from the well bore to the surface. So you want to be able to transport your hydrocarbon successfully from the reservoir to the surface for separation and exportation, and exporting it for commercial trade. In order for you to be able to do this, you need to know your fluid density. In order for you to design a well bore that can easily and seamlessly carry out this activity that I have mentioned, that's moving your hydrocarbon from the reservoir through to the surface, you need to know your fluid density, you need to know your viscosity, your compressibility, and key well bore. So this, and not just even as a petroleum engineer, also PVT analysis is very important for drilling engineering. It's very important to the drilling engineers in cases of lost circulation. So the knowledge of your density, the knowledge of your fluid density is very important in when you're drilling, because it helps you to avoid situations like your kick, lost circulation. So not only is our PVT important for petroleum engineers, it's also important for drilling engineers, or is important in cases of drilling engineering. Now, I've been mentioning different parameters that I have said will be used in calculations. The knowledge of this parameter will be very important because it does X, Y, Z. What are these parameters? Our PVT parameters is classified into three. We have the volumetric properties. We have fluid properties, because the PVT parameters are basically fluid properties or properties of our hydrocarbons. And now these properties have been divided into three. We have the volumetric properties, which looks at the volumetric properties basically look at how your variation in pressure affects the volume of your fluid. And in this case, some of the volumetric properties are density. Density is a volumetric property. Your formation volume factor is a volumetric property. Your solution gas oil ratio, also known as your gas solubility, is a volumetric property. Your compressibility and also the specific volume. These are all volumetric properties. What is your density? We know density to be the measure of the ratio of mass to volume. But in real sense, density is, let's say you have a volume of water. You want to measure how much does this water weigh? What's the mass of this water? That is density in a layman's term. The measurement of the mass of a substance. You have a volume of a substance. How much does this volume weigh? That's density in a layman's term. Then our formation volume factor. Our formation volume factor is the measure of the volume of our hydrocarbon in the reservoir to the ratio of the volume of our hydrocarbon in the surface. Because, let me explain this so that you understand clearly. You know, let's take, for example, you have an undersaturated reservoir, for example. An undersaturated reservoir, I've said it is a reservoir in a single phase. So we have it in, for instance, let's say we have an oil reservoir. Undersaturated reservoir will be one in just liquid phase. So we have just crude oil. But with this crude oil, we have gas that have been dissolved in the crude oil. So yes, the crude oil is in liquid phase. There are gases embedded in this crude oil. But because it is an undersaturated reservoir, it is coming in as a one-phase liquid or one-phase flow. But upon production, when these are undersaturated reservoir fluid, this fluid in one phase, when it experiences decrease in pressure, the gases that have been dissolved in oil will then be evaporated. So if you remember from the phase diagram that I was saying, when you're coming from a place of higher pressure where you have just liquid and fluid hits the bubble point pressure, you then begin to experience gas. So, okay, let me use this analogy for you to understand clearly. You have your Coke. You know your Coke, when you buy a Coke or when you look at a Coke, you're basically seeing just liquid, your Coke in the Coke bottle. But when you open the Coke, you hear, there's a sizzle you hear in the Coke. And sometimes you can see bubbles of gas, or you see bubbles at the top of the Coke when you're opening the Coke bottle. The Coke at initial state, when you not open it, is what we know as your undersaturated reservoir. So the coke is just liquid, but there is gas dissolved in this coke. But when you release the pressure from your coke bottle, when you open the coke bottle and you release the coke bottle has been at a stable state, you open it to release pressure from the coke because you want to take the coke. You begin to see bubbles of gas evolving, which is the same thing as your undersaturated reservoir. So your undersaturated reservoir is in liquid state or is in a liquid phase, but we have gases embedded in it. When this undersaturated reservoir now goes through a process of pressure depletion, you begin to see the bubbles of gas that were initially dissolved in it evolving. And when this happens, it causes your volume of your crude oil to reduce, because with reduction in pressure, you have expansion of your fluid because your gas is being liberated or your gas is being evolved from the crude oil. So when the gas leaves, your gas that was initially occupying space in the crude oil, when it leaves the crude oil, it causes your crude oil to shrink. Hence why the volume of your hydrocarbon will not be the same as it was in the reservoir. In the reservoir, for oil reservoirs, you have your volume in the reservoir more than the volume in the surface, because that's your oil, that volume of oil that you took from the reservoir has experienced a change as pressure was depleted in the reservoir. So formation volume factor basically measures what this variation is, which is why you have your, if you remember your BO. If you want to calculate your BO is your volume of oil in the reservoir divided by your volume of oil at the surface. And when you do this calculation, you see that your BO is usually greater than 1. Why? Because the volume of your oil in your reservoir will always be greater than that in the surface, because there's been a change in the phase, or gas has evolved from this oil. But if you look at the formation volume factor of gas, your BG now, your BG, which is also still the same formula, your BG. Please, can you hear me? Because you said my connection was lost for a moment.
Yes, we can hear you now.
Okay. So I was trying to explain the formation volume factor and how they differ in your oil reservoir and your gas reservoir. For oil reservoir, you would always have your formation volume factor greater than 1. While for your gas reservoir, because with gas is a very compressible fluid. Gas expands as you release pressure. If you put a gas in a small container, you transfer that gas to a bigger container, the gas basically takes up the space of that container. So with gas, there's always expansion. If you give gas the room to spread, it will continue to spread because of the intermolecular forces acting in it. So with gas reservoir, the volume of your gas in your reservoir is usually smaller than that in the surface. Why? Because when the gas comes to the surface, like I said, it always has room for expansion. So your gas keeps on expanding as much as the space you give it. So your volume of gas in your reservoir, and because when your gas is coming to your surface, or when your gas is in the reservoir, it's usually most times dissolved if you're coming from an undersaturated reservoir. But a saturated reservoir is one in which your gas, you have like a gas cap, because your gas has been evolved from your oil. So with your gas formation volume factor, you find out that your gas formation volume factor is usually less than 1. Why? Because the volume in the reservoir is usually smaller than that of the volume in the surface. If you've been wondering why our BO If people wonder why BO, when they give you BO in class, your value for BO is usually greater than 1. This is the reason, because the volume of your crude oil in the reservoir is usually more than that will be recorded at the surface, because of, by virtue of gas being evolved from it. So it causes a shrinkage. The next volumetric property that is being gotten from your PVT analysis is your solution gas oil ratio. So your solution gas oil ratio, also known as your gas solubility, is a measure of your dissolved gas in oil. Because like I've said, initially when you're starting out from an undersaturated reservoir, you have your gas being dissolved in the oil. And as you produce, or as your pressure depletes, you have gas now evolving. Once your pressure hits your bubble point pressure, your saturation pressure, you have your gas now evolving from that oil in the reservoir. So as you continue production, the amount of dissolved gas that was initially recorded in your reservoir would always reduce, or your solution gas oil ratio tends to reduce as pressure reduces once it reaches the saturation pressure, because with production, you're producing, getting to your bubble point, coming from an undersaturated reservoir, you have your solution gas oil ratio fairly constant because the volume of your gas in the reservoir is fairly constant. But once it gets to the bubble point pressure, where you now have your gas being evolved at its own pace, like it's almost like you're giving your gas free will to fly, the gas that is now still dissolved, or the gas that is estimated to be dissolved in your oil, would reduce because the gas is now evolving and going out for production. So your solution gas oil ratio would, if you plot the curve of your solution gas oil ratio to pressure, your solution gas oil ratio would reduce, or you would observe that there will be a reduction in solution gas oil ratio once it gets to your saturation pressure. Compressibility now looks at, like the name implies, we have compressibility of rock and compressibility of also fluid. Gas is known to be a highly compressible fluid. Compressibility basically looks at how the volume of your crude oil or the volume of your hydrocarbon system changes when being subjected to pressure. So when you reduce your pressure, and compressibility looks at volume and pressure. It takes into account your volume and pressure. When you reduce your pressure, when there's a reduction in pressure, there's usually expansion in your crude oil or in your gas. So compressibility looks at how our crude oil, the volume of our crude oil changes when subjected to pressure. Then we also have specific volume. Specific volume is the inverse of your density. Moving on to the next classification of PVT parameters, we have the transport properties. Now, this properties basically tells us how, or it looks at how fluid properties that relate to flow, how they change with respect to pressure change. So your viscosity is a fluid property. These are properties that influence your fluid flow. You know, when you have a highly viscous fluid like oil, the viscosity of gas is noted to be lesser than that of the viscosity, or lower than that of the viscosity of oil. Viscosity is a transport or is a fluid property because it influences your flow of fluid. So viscosity basically looks at, or this parameter looks at your resistance to your flow of fluid. We have your diffusion coefficient. Diffusion coefficient tells us how our fluid, how the oil and the gas, how our components, how the rate at which they mix, the rate at which your gas will mix, how it is soluble in oil. And this information is very important. Your diffusion coefficient is very important in cases where we have to do secondary recovery, because we have primary recovery method, we have secondary recovery where we have your gas lifting, and you have where we do gas injection. In order for you to be able to carry out gas injection in your well in such a way that it can produce or drive the flow of our hydrocarbons from the reservoir to the surface, you need to know what kind of how well with this gas that is being injected, how would it react with the fluid in the reservoir. Information like that is gotten from our diffusion coefficient. So the knowledge of our diffusion coefficient will tell us how our fluids interact, or how well they mix, the rate at which they spread or they mix with one another. While the thermal conductivity basically looks at the heating, the rate at which our fluid heats, the rate at which the temperature of our fluid is being transferred. The third classification of our PVT parameters we'll be looking at is the thermodynamic properties. And these thermodynamic properties basically tells us the information of the heating capacity of, if we want to know the heating capacity of our hydrocarbon system, the thermodynamic properties tells us information where you have your enthalpy being your enthalpy to be the total heat or total energy of your fluid, while the entropy looks at the rate of disorderliness in our fluid. And we have the Joule-Thomson effect. Joule-Thomson effect is the higher pressure to lower pressure. So when our gas goes from when you have a gas cylinder, the gas please confirm you can hear me and you can see my screen.
Yes, we can hear you. We can hear you now, but we can't hear you.
Sorry. I'll go to sharing my screen again.
Yes, we can see you now.
Okay, yes, thank you very much. So I was trying to explain the Joule-Thomson effect and how it works. So the Joule-Thomson effect tells us how our fluid will behave when it is passed from a place of higher pressure to lower pressure. When our fluid moves from a place of higher pressure to lower pressure, there is a change in the temperature. And I was giving an analogy of your gas cylinder. If you have a gas cylinder and you're trying to connect the head of your gas cylinder to the cylinder, you notice that when you try to turn it like clockwise to close it, the gas that comes out from your gas cylinder is usually cold. Why is that? Because your gas is coming from a place, the knob, or where you're trying to connect the head, the connecting point of your the head of your gas cylinder is a small knob where your gas is penetrating or it is coming out from. And now your gas is coming from that tight pressure to your atmosphere where you have lesser pressure, where you have your atmospheric pressure. And it's coming from a higher pressure to a lower pressure. If you notice, or if you paid attention, you see that, or you feel that the temperature of your gas is usually cold. That is what the Joule-Thomson effect tells. It explains, or it gives us information on the temperature of our hydrocarbon, or the temperature of our gas when it moves from a higher pressure to a lower pressure. Then you have your specific heat capacity as the last thermodynamic property. So all these properties are fluid properties that all these properties are fluid properties whose information are gotten from the PVT analysis. So you get your density, your formation volume factor, your viscosity, your diffusion coefficient, your specific heating capacity from PVT analysis. So now we've been speaking on the PVT analysis, its importance, the parameters that we are getting from the PVT analysis. But how then do we get these parameters? Or how are these parameters that how do you obtain your oil formation volume factor, your gas solubility, your viscosity? It's gotten from fluid sample. So we would actually need a sample of the crude oil in the reservoir in order for us to be able to estimate all these properties that I have listed. And the acquisition of this sample, or the acquisition of our crude oil sample, is known as your PVT sampling. And so PVT sampling is the acquisition or the process of acquiring our reservoir fluid. And with acquiring your reservoir fluid, we want a reservoir fluid that is a representative or a representation of what is in the reservoir, because we cannot take all the hydrocarbon in the reservoir for us to be able to say, okay, this is our density, this is our viscosity. We need a sample of what is in the reservoir, a representative sample, to be able to make inference or make decisions, to be able to obtain these properties, these parameters that I have mentioned. And we have two ways in which our sampling can be done. It is very important, again, to take a sample that represents our reservoir in the best way possible, because if you take a sample that does not represent the reservoir in the best way possible, we're going to make decisions based on that sample. And imagine making your choices of your imagine making your decisions on your choices of your separator, your choices, the decision on the pipeline size based on a wrong information. It means all the effort you're going to do, all the money that will be invested in the project will go to waste, because we made a decision based on a sample that doesn't give us as much information as possible as we need. So there are two ways in which we can obtain samples of crude oil. We can obtain sample from downhole. We can obtain sample, or the two methods are, we have the downhole sampling method and we have the surface sampling method. The downhole sampling method is also known as your bottom hole sampling. And this process basically involves you sending in a sampler, a container with you send in a container, sorry. You send in a container with nitrogen. We use nitrogen to maintain the temperature and pressure, because you're trying to get a sample, again, that represents what is in the reservoir. So you're trying to get a sample that has the same pressure in the reservoir and has the same temperature in the reservoir. So when making acquisition of the samples of our crude downhole, we send in a sampler. We also send in something that would help maintain that temperature and pressure and bring it to the surface to use for analysis. The second sampling method, which is the surface sampling method, is the acquisition of a sample, like it says, from the surface. So you can either do that from the wellhead. You can take samples of your hydrocarbon from either the wellhead or from the separator, either from the liquid, the oil leg, or the oil outlet or the gas outlet. And when you do sampling from your separator, it means you're going to do what we call recombination, because now you're taking your sample in two phases. But in the reservoir, especially if your sample is an undersaturated reservoir, you know that your sample is going to be in one phase. So you're going to have to recombine your sample, that's the oil and the gas, to model what is in the reservoir. Then we can now carry out any analysis that we want to carry out on that sample that already now looks like what is in the reservoir. So you either obtain from this separator, like I said, or from the wellhead, or you carry out downhole sampling. Downhole sampling has been identified to be like the most effective, because you're taking the sample from the source. But if you want to carry out your downhole sampling, you carry out downhole sampling before production starts, because once production starts, you cannot be able to carry out downhole sampling again, because you've altered the you've altered the reservoir condition, or you've altered what is in the reservoir. So then you carry out surface sampling. And downhole sampling is very expensive. If you want to carry out downhole sampling, it's very expensive as opposed to carrying out surface sampling. And one of the drawdown of your downhole sampling is that with downhole sampling, you can only carry as much as your sampler can contain, which is a small quantity of hydrocarbon. But with surface sampling, because you can sample at your separator, you can sample at your wellhead, you can carry as much sample as needed, and you can do surface sampling multiple times. It's not just at the beginning of your production. You can do surface sampling in the course of your production. At different times, you see people go to take samples to analyze. So surface sampling can be carried out at different in the course of your production, while downhole sampling can only be carried out before production, and it is very expensive, and it also can just take a small quantity as opposed to your surface sampling. This is a representation of this is how your downhole sampling is. So you're basically sending in a sampler. This is the sample chamber to get samples of your crude oil from a desired depth in your reservoir. While for the surface sampling, you can either carry it out at the wellhead or at the separator outlet, whether it's the gas outlet and the oil outlet, then you carry out what we know as recombination. But there are different factors to note when carrying out sampling. You don't just sample because you don't just do downhole sampling because you want to do downhole sampling, or do surface sampling because you feel like doing sampling. You carry them out considering some factors. And like I said, you're carrying out your sampling, or you want to get a sample that is a very good representation of what is in your reservoir. So if your reservoir is an undersaturated reservoir where you have your fluid in one phase and you want to carry out what we know as surface sampling, there are some criteria that should be checked. The information of your separator gas oil ratio, the knowledge of your separator gas oil used in. Sorry, please confirm you can hear me because my network is fluctuating.
Yes, I can hear you, ma.
Okay, thank you very much. So there are some factors, like I said, that we take into consideration when you want to carry out your sampling. The cost of the sampling method, the amount of fluid you want to get, what volume of, if you want to get a large quantity, then you know you have to carry out surface sampling. But with carrying out surface sampling, you need to remodel it in such a way that it represents what is in the reservoir. So this shows us the different kind of sampling method and different types of reservoirs and which is best suitable for the reservoirs. So for black oil, all the reservoirs, for all the reservoirs, you can carry out surface sampling. What you need to do is recombination, and you're going to recombine it using either the gas oil ratio information, or you recombine it using the saturation pressure. Because once you have a saturated reservoir, it means the reservoir is either at the reservoir's pressure is either equal to your saturation pressure or is lower. So the information of your saturation pressure is another yardstick, or is another criteria used in your recombination. So for the black oil, the volatile oil, all the types of the fluid type reservoirs we have, surface sampling is the surface sampling method can work for them. But for bottom hole sampling, when you have a reservoir like black oil, for the black oil reservoir, when you have an undersaturated reservoir, you have it in one phase. You can carry out your bottom hole sampling for the black oil reservoir. For volatile oil reservoir is one that in the reservoir is usually oil. But when it comes to the surface, it has a very large gas oil ratio. All this information, I feel like you would already know the different distinguishing factors of your black oil, your volatile oil, your gas condensate. There are different properties that they have. Your volatile oil has a gas oil ratio, has a very high gas oil ratio as opposed to your black oil. And your volatile oil basically experiences, they usually call it a high shrinkage. Why? Because your gas oil ratio is very high, meaning when your fluid comes to the surface, you would have a lot of gas in, or when you're doing your separation, you will record that you have a lot of gas and your liquid would shrink as opposed to what you observe in the reservoir. So carrying out bottom hole sampling on a volatile oil is very good, and carrying out bottom hole sampling on an undersaturated black oil reservoir and an undersaturated gas condensate reservoir, because gas condensate reservoir also acts like your volatile oil. But in this case, you're recording a lot of condensates in your gas condensate reservoir, which is also known as your retrograde condensate reservoir. So in the reservoir, it is usually gas. But when it comes up or when it experiences reduction in pressure, you find out that you have a large volume of condensates being condensed from your gas condensates. So carrying out bottom hole sampling on your gas condensate would work for the gas condensate reservoir. Well, for all the different types of fluid type we have, the reservoir, surface sampling is very good for them. You just need to recombine to remodel what is in our reservoir. So I'll be rounding up with my segment, or with my part of this PVT training. My part was to just introduce you to what the PVT analysis is and its importance to you as a petroleum engineer. The knowledge of PVT, why is it important? Why should you know what PVT analysis is and what role does it play in the oil and gas industry? Then to also look at the various properties or the various PVT parameters we have, of which I classified in three, of which I distinguished in three classifications. You have your volumetric properties, you have your transport properties, which aid your fluid flow. Then you also have your thermodynamic properties, which look at your heating, basically they are your heating properties of the fluid. So, and we also looked at the sampling method, what sampling is, what PVT sampling is, and the different types of PVT sampling method we have, and which sampling method is best for the different kinds of reservoir we have, and which sampling method should you use, why should you use a sampling method. We looked at that. So at the end of this, I believe that we have been able to establish the importance of PVT and what PVT analysis is, which is, it gives us a thorough understanding of the fluid dynamics, and it's very vital in reservoir engineering. It's very vital in understanding the behavior of our fluid. It's also very vital in knowing if our reservoir is, or if the hydrocarbon, what we have located, if it is economically viable, should we go on with this project or should we not go on with this project? Information of the information gotten from our PVT analysis helps to tell us this information. So I have come to this, with all this, I've come to the end of my session today. And just to know if we have gotten a thing or two, I'm open to answering any questions. If you have questions, please either drop it in the chat box or you raise your hand, signify by raising your hands. Then I'm open to taking any question. But in the meantime, before we take any question, I would like to test our knowledge to see if we've gained a thing or two from today's presentation. And I would like my colleague Samuel, I think Samuel, please unmute yourself if you're on the call.
Okay, thank you for the presentation. I'm here. So can we quickly go to the question and answer why I make the questions properly ready, because I need to change the device I'm using currently.
Okay, no problem. So I'll be taking questions now. If we have any question, you need clarification on anything that has been said, please signify by raising your hand. Or if you have any contribution to make, because like I said, I'm learning from you, you're learning from me. So if you have any contribution, you have anything you want to gain clarity on, please indicate either in the chat box or you use the raise hand feature, and I would call you, the raise hand icon, and I'll take your question. Please confirm you can hear me.
Yes, we do.
Okay, I hope I did not confuse you. If you have any questions, you have anything you need clarification on, please indicate. While we wait for Samuel to get the questions ready, just very simple questions to know if we've gained something from today's session. Well, tomorrow we'll basically be looking at the ways in which we actually get our PVT parameters. So we'll be looking at the laboratory experiments.
There's a raised hand, Daniela, Olayemi Ogundele. Can you go ahead?
Okay, Samuel.
All right. I just want to call your attention that I'm ready if we can go ahead with the questions.
Okay. Okay, I think we can go ahead with the questions. Since there are no questions for now. But please, if you have any question, drop it in the chat box or just indicate by raising your hands.
All right. So let me see. Let's quickly just rush into menti.com while I try to share my screen. And going there, we should use this code, menti.com. I'll type it in the chat box. Menti.com. I think I get that correctly. All right, so let's use this code. Just go to your browser. Okay. Okay, I can use this link. Okay. So let's keep joining. Seeing 5 players there already. Okay, let's join quickly so that it's just.
For password.
I didn't get that.
Someone was asking for password.
Oh, okay. Can you go through that link? And if you still require code, I will quickly type it 663877062.
It's not needed. Not needed.
38. So that's the code. So we have 11 players already. In the next 1 minute, I would like to go ahead. So keep joining. Keep joining. All right. Before we start, let me try to share my screen. Okay, please, someone is sharing. I don't know if it is still Daniela. I cannot share the screen without the person stop sharing. Okay, I think I can go now. All right, so we have 11 players, so let's go ahead. So the faster you answer, the more points you get. So all these are the importance of PVT analysis, except as discussed earlier. So I have 5 answers already. All right, so out of the 8 attempted people, only 1 person got it wrong. So we'll move on to the next question. So gas oil ratio, compressibility, formation volume factor, density are all examples of what properties of. Okay. So 10 people got that right. So it's volumetric properties. So the transport properties are just viscosity and the likes, why the RS, BO are all volumetric properties as discussed earlier in this call. So the next question. So the change in temperature when fluid moves from higher pressure to lower pressure is a term known as what? Is it specific heat capacity? Is it enthalpy, entropy, or Joule-Thomson effect? So 9 people attempted already, and 8 people got it right. So actually somebody said enthalpy, so but the correct answer is Joule-Thomson effect. So supposed to. Okay, the 4th question. Sampling is saturated black oil at the bottom oil is advisable. Are you advising we can get our oil in saturated region from bottom oil? So divided opinion. So the answer is definitely false. It's advisable to get our sample when it is saturated because we want to get that sample as much as possible in one phase when we are talking about bottom hole sampling. That is better for undersaturated. We can naturally get bottom hole sampling, but when it comes to more than a phase, so it's better to do the sampling at the surface. So that should be the end of the question, but I don't know what I have next here. Okay, just the leaderboard. So let's see what our final leaderboard is. So we have Philip to be the fastest person here. I will say both here. Then we have Jude T. Mark coming second, then Cake, then Jonathan. At least everybody here got a good point, so which means we have a good knowledge of what was being discussed earlier. So thank you. So I'll stop sharing from here. We'll go back to taking the questions.
Okay, thank you very much, Samuel. I see that we have 2 questions. I'm coming, sir. Please hold on. We have 2 questions in the chat, but please, if you have questions, you either drop it in the chat or you raise your hand. And the first question, please, can you explain more on the recombination method? Okay, so please confirm you can hear me clearly. Okay,
Yes,
thank
we
you very
can hear you.
Thank you. So The recombination is done, like I said, when you take your crude oil samples from the surface. When you take from the separator, you're taking from the outlet of the oil and the outlet of the gas. And when you take those two samples, when you take those two samples, they are not a representation of what is in the reservoir, because you want a representation. That's not how, when it came from the reservoir to the surface, it did not come separately in oil and gas. It was in one single phase. So you're recombining to model, to give us what is in the reservoir. So you're recombining basically to model what the reservoir looks like. And how can you even model what the reservoir looks like when you have information on your gas oil ratio? So if you have information of your gas oil ratio, you can do your recombination in such a way that when you recombine, the crude oil samples that you've recombined has the same gas oil ratio as what is in your reservoir. So that's why I said there are different factors that come into play when you're doing sampling. There are different criteria that should be used as yardstick: your gas oil ratio, your saturation pressure if you're dealing with a saturated reservoir, knowledge of your saturation pressure. So you're going to remodel, you would subject your sample to a pressure that you subject your sample to the pressure of what is in the reservoir. Same, you subject your sample to the gas oil ratio that our reservoir has. I don't know if you understand what I'm saying. I don't know if this person gets me. Ahmad, do you have I cleared you on your question? How the recombination work? You're basically subjecting your crude oil sample to temperature and pressure, because when your crude oil sample comes to the surface, they are now in atmospheric, they are being subjected to atmospheric conditions, which is not the condition of what is in the reservoir. In the reservoir, they have very high pressure and also high temperature. So you're going to subject that crude oil sample, you mix it, then subject it to the same temperature and pressure condition that has been recorded by your geophysicist or your geoscientist or even the reservoir engineer, what they recorded as the initial reservoir temperature and pressure. You would subject the crude oil sample to that temperature and pressure condition, and you also subject the crude oil sample to the same gas oil ratio. So we're going to have the if your gas oil, let's say your gas oil ratio is 500, excuse me, let's say you have a gas oil ratio of 500, you're going to subject that your crude oil sample, you're going to recombine it in such a way that it has the same gas oil ratio, so that it can give us what is in our reservoir. Ahmad, please confirm you're clear. Or if you
Yes,
need
I
any other
understand
clear.
clearly. So mean that while we are doing that surface sampling, we initially have our temperature and pressure. Is that clear?
Sorry, come again, please.
So I mean that while we are doing our surface sampling, we initially have our initial temperature and pressure while we are doing surface sampling.
No, when you're doing surface sampling, you're taking your samples at the pressure of what the separator is, because with separators, especially with the way our facilities are designed, you have different, when you're dealing with multi-stage separation. So you have a separator of, you have your first stage separator, your second stage separator, and as your separator goes to different stages, the pressure and the temperatures are reduced. So the temperature at your first stage separator is not the same. The temperature and pressure at your first stage separator is not the same as the temperature and pressure of what is in the reservoir. So if you're taking your crude oil sample from the first stage separator, you're taking your with the separator, you have one inflow, then you have your crude oil outlet, you have your gas outlet. So when you're taking your sample from your separator, you're taking your sample from the oil outlet and gas outlet, and they've already undergone pressure and temperature depletion. They've undergone reduction in temperature and pressure. So, and that temperature and pressure is not what is in our reservoir. So you recombine it and subject it, put it under a pressure and temperature of what is in the reservoir. So it doesn't have your temperature and pressure of your crude oil sample, your separator is not the same as the temperature and pressure of your initial reservoir.
Yes, ma, I get it. Just to confirmation, because we said we should subject it to the temperature of the reservoir and the pressure of the
Yes.
reservoir. So that means that we know the temperature and the pressure of the reservoir. Yeah?
Yes.
Okay. All right.
Yes.
Okay.
Okay. Then
All
sorry?
right. No problem. I just want to chip in something. So
Okay.
I think you just so the whole idea is how much? So you have the temperature and the pressure of that reservoir initially. So that's even what makes the whole thing make sense, because you want to, when you are trying to do, the reason you are trying to do the recombination is you are at the surface, there's separation already, being a liquid and a gas that's been separated. So at the end of the day, you want to have this this combined so that you have the representative sample of what is expected from the reservoir itself. So if you are doing bottom-most sampling, you don't have any concern doing recombination. It's just you trying to get your tools ready and making sure that you get the sample when the time is right for you to get it. That is prior, when you condition your well very well, then prior to production. So that's coming to the surface now. You just get those sample from the gas and from the liquid, from the gas and from the oil. So you now take it and combine it. Then you have a reference point, which is the initial reservoir pressure and initial reservoir temperature. So that would be like a yardstick for you to measure when you are trying to do your recombination. Okay, if you are recombining and if that condition has not been met, which means you are not having a representative sample of what is on the ground already. So it's very, very important. So the knowledge of initial reservoir pressure and initial reservoir temperature is already there. So you are just using it as a yardstick when you are trying to combine and getting a representative sample of whatever you are combining at the surface. Thank you.
Okay, thank you very much, Samuel. Second question from Philip. How does PVT analysis help in multi-stage separation at the petroleum surface? Okay, very good question. So, PVT analysis, from the PVT analysis, I've repeated over again that you get your dissolved gas oil ratio, you get parameters that will be used in the designing of your facility. These separators that you see on site, when you go to site, the separators that you see, all the equipment you see, those pipelines, they were not just built because they were built, like they just wanted to be built that way. They were built using the information from the reservoir, the type of crude oil or the type of hydrocarbon they have in the reservoir. And knowledge of those, knowledge of your oil formation volume factor, knowledge of your density, knowledge of your gas oil ratio helps in designing designing your separator, helps in designing your pipeline to know the how big should this or how big should this separator be, what's the size of our pipeline. Information from your PVT is used in designing the separators and all those I'm trying to remember all the facilities on site, but your separators and all those things you see on site, the information of your PVT parameters is used in the designing of those facilities. Philip, please, I don't know, are you clear on your question? So basically, the PVT parameters are used, those parameters are used in doing the calculations for getting the size of our surface facilities.
Okay, so what I'm asking is how do they do it?
Okay, how? Okay, so
Yeah, I'm done, yeah.
sorry.
Yeah, I'm asking how do they do it? I know they use PVTs, but how do they do it? How I'm asking. Like
Okay, so
I don't
when
know.
you at the time, can you hear
The
me?
reason is, yeah, yeah. Can you hear me too?
Yes, I can hear you.
Okay, so I'm saying I've tried to grab some. I've read about it, but then I don't really get it like that. So I'm just asking to just clarify how they actually, yeah, PVT helps in, because there's a way they run it for multi-stage separation like that. That if they want to, like, let's say if they want more oil, there's a way they condition it. And if they want more gas or something, so the PVT tells them how to condition it and how to, optimize what they want to get, if it's
So
more of the oil or.
the PPT gives them the information they use in the calculation that they use to condition. So the PPT gives you your density. The PPT gives you your gas oil ratio. Already we have correlations that are used in, you have your mathematical formulas that are used in getting this separator size. There's a formula to calculate the size of your separator, if it is a vertical separator or is a horizontal separator. So from the PVT now, you're going to be getting the parameters of that. That's like you're basically getting your formulas. You're getting your density. You're getting your temperature. Sorry, you're getting because already you've measured your initial temperature and pressure. You're getting your separator temperature, your separator pressure. You're getting your gas oil ratio. You're also getting the density of your hydrocarbon. So now this is what will now be used in those correlations or those formulas to now know, okay, this is the size, or this is the inch, this is the size of the facility, the size of the facility. In this case, let me say a separator or a pipeline.
Okay.
I don't think you're clear. Are you clear? You don't sound like you're clear with the explanation.
No, I'm good. I'm just flex.
Are you sure?
Yeah. Well, I think there's more to it, Sha, but I think you did justice to what you can. Yeah, you tried. Yes.
Okay.
Yeah.
I don't think we have any more questions, or if we want to add to what has been discussed today, you can feel free. Just raise your hand. But in case where there's no question or no contribution, I have come to the end of my knowledge sharing today. And I want to thank once again Abuja section for this opportunity. I want to thank Dr. Ike especially for this opportunity. I also want to thank the Student Affairs Chair and Co-Chair, and also CEO of Cypher Crescent for this knowledge sharing opportunity. Thank you very much.
Thank you, thank you. You can give Daniela some virtual applause. Thank you for taking our time to respond to all of the questions. And of course, we continue with the event. I believe all our student members are already registered with SPE. If you're not a registered student member, it's necessary that you contact the Student Affairs Chair or your president, and you will be guided on how to have your membership active. This event and our past event has been live streamed on YouTube, so you can always go to YouTube to watch and refresh your memories, as well as tomorrow is also going to be on YouTube. So please endeavor to visit our social media platforms from Instagram to LinkedIn to Facebook, and of course Twitter, formerly called, I'll be now called X, and you get all of the information. I'd like to switch gears immediately and invite our Student Affairs Chairperson for her vote of thanks. Over to you, Chinaza, please.
Okay, good evening, everyone. Please, can anyone confirm that they can hear me?
Yeah, we hear you, ma'am.
Okay, thank you very much. So before I proceed, on behalf of Student Affairs Chair, first of all, I'd like to say that she sent her greetings. She's unavoidably absent. Last week, we had the very first edition of our Student Affairs series where we invited some guest speakers, to speak on OPEC. And I know that some of you here may be wondering why the Student Affairs body is bringing this series. Now, I understand that we know very well that health is wealth, right? But then we also understand that knowledge is wealth as well. And that is why we have put together this series to help our students grow and, become better people. As such, I would love to thank the section chair, Dr. Ike, for his continuous support. I would also love to thank the board members and, SP Abuja section for partnering with the Student Affairs body to see that all our activities are planned out properly. I would also love to thank Cypher Crescent for choosing to partner with us. Thank you very much, Daniela, for your wonderful presentation. I was very impressed to see the outcome of, the knowledge test. Thank you very much. We appreciate it. To our students here, thank you very much for making out time to come. I understand that you might have things that you've planned out to do, but you need to understand that no time ever wasted when it comes to learning. No time spent, I beg your pardon, when it comes to learning is a waste. You might not see the need for it now, but eventually in the future, what you have learned today, you would find out that it has been very, very helpful. Thank you so much for making our time to be here. As mentioned earlier, day 2 is tomorrow, same time, 4 p.m. If this is just the introduction or the day 1, you can imagine what tomorrow would be like. So thank you very much for coming. I expect to see more numbers tomorrow. So if you are here today, please try as much as possible to invite your friends. They don't need to be part of the SP Abuja section. They don't even need to be students. You can invite professionals that you know to come and learn. Thank you very much. And thank you to Apan for your moderation. Excellent as always. Thank you very much. See you tomorrow. Thank you.
Thank you, ladies and gentlemen. So we come to the end. Of course, see you tomorrow for the wrap of this Student Affairs series. Bye for now.